Hello everyone, George here, and in this video we're going to tackle the animatronic class. Now, so in the last video we had finished up with making it so that there were triggers for time increments or transitions occurring, and the AI manager was then going to trigger in the characters this transition, and it was through this animatronic script that we created. Now the animatronic script itself wasn't very complicated, and we had just started filling in some different things such as a enumeration called actions. And these would dictate later on to our animation system what pose the character should actually be in. We'd also put together a struct, which pretty much was just there to house the enumerations as well as weights, which were bool values. And the weights simply are going to be used to tell us whether or not we can or can't enter a particular node. Now, for every animatronic in the game, they will have their own list like this. I don't really want to use the inspector as it is to try to deal with these values. It might be kind of cumbersome, and I don't want to have to move between lots of different objects to do this either. So what I'm thinking of doing is creating an editor extension, and basically this is going to change how the inspector handles this particular class. What I have in mind is that the inspector for the animatronic script will show the start node, which you can place in here. It's going to be of type node. And the start node is where this particular character will spawn at the beginning of the game. Below the start node is going to be information that's going to specify the node name or the node number, whatever we end up dealing with, but it's going to be its name basically. So we have different nodes for each of the different rooms or any locations in a room that are unique. Next to the node number or name is going to end up being the enumeration, and you'll be able to select this with a drop down to pick any of the different kinds of states. So the idea is for this particular location, let's say it's the party room. In the party room, you'll pick the action type that has the character standing, right, or on stage. And the last thing you'll have is a bool value back here, and this bool value is going to be on or off. It's going to be a checkbox. And if it's on, it means it's a location we can go to. If it's off, we can't go there. All right? So that's what I want to do. So this way, I'm going to have, each character. So character 1 is going to have its own list like this. I can set it up, and when I run the game, it'll know how this character should behave. Same thing with character 2 and character 3. They all have their own unique ways of dealing with this. Now, this system right now isn't completely perfect and not fully finalized, at least the one I have in my head. So it might be some tweaking in future videos, especially with how I'm dealing with nodes. Right now I'm probably going to have them as an array, but I probably want to do something with a dictionary or at least create some sort of a lookup table so that I can move between the AI manager's representation of nodes as well as the character's representation of nodes. Let's go ahead and jump right into code and get this thing started. So the first thing we need to deal with is the fact that we're going to be creating files that directly involve the editor. And to do that, we're going to right-click here and create a new folder. Now, I'm just going to warn you right now, I'm not an expert in this area at all. I did some reading, did some research, and this is a solution I figured out after some testing. It's not complete yet, so I'm going to kind of wing it a little bit, but for the most part, I've already taken some time to figure out how this is going to work. According to conventions online, we're going to do Animatronic Editor. Doesn't have to be this name, but typically they like to have the name of the class you're dealing with followed by editor, and that's going to be inside of the edit folder. So let's go ahead and open that up. Go back over here, go under the scripts folder, and find animatronic and open that up as well. So here's where we left off. We've got those actions. We're going to leave that as it is, and we have this public struct mode. Probably going to change that name, but in there we have a bool weight and an actions action. Now the first thing we're going to need to do is and I found this out the hard way with some testing, is the fact that, so when you create your own custom classes or enumerations or structs, and things are not directly inheriting from monobehavior, these objects won't be saved out inside the editor. That is, the way Unity's system appears to work, if we come back over here really quick and I close that out and fill that in. As I understand it, the way it works basically is that if you have your own custom classes or types of any kind, and you don't specify that they're serializable, what's going to happen is Unity is not going to know how to save this information out. So when you're inside the editor, for instance, and you make changes to different objects, such as game objects and scripts, Unity serializes those changes, and it saves them out. Then when it runs the game, it creates copies of these objects when you press that play button. those copies are directly from the serialize. That is, it does a deserialization. If it is unable to serialize, it is not going to be able to deserialize either. Therefore, all these values get a null value placed in. And this is where you end up losing everything, all the work that you did. Worse off, when you've done this and now you go back to the game, it's going to deserialize those serialized values from back here. But since they were not serializable, guess what you get back in your inspector? Null. And you lose all of your work. Therefore, we need to make sure we go through and make these different objects serializable. Now, if you're using mono behavior, for instance, it's serializable. It's going to work with all those public fields. So let's go back into Unity and fix all that up right now. Okay, so the first thing we want to make serializable is this one right here. So we're going to do that by making a bracket and doing system.serializable. Now this will be able to be saved out by Unity. It's going to be able to be serialized so that this information can be stored, serialized, and then deserialized later on. Now right now I'm calling this mode. I wanted a name a little bit more specific. So let's go with animatronic, if I can spell it right, animatronic node data. Yeah, very long, but more specific and to the point. Let's do system.serializable. Bools are easily can be serialized. Actions can now be serialized because we said this so up there, and now this entire struct can be serialized as well. Now we already have our public game object start location, but I don't want this to be a game object. I actually want this to be of type node, which we created in the last video. The idea is the start location is going to tell our animatronic, whoops, that's the wrong name. I was doing some testing with this class before this video, so I named this old so I wouldn't lose any of my work, and I wouldn't have to try to reverse engineer what I'd done beforehand. Okay, so in start, what we're going to want to do is start location itself. We're going to use that node's information to determine where that object should be. So if we come back over here, here's our different nodes, and they have different orientations, as well as, I'm going to rotate, there we go, positions and orientations. So let's come over here, and in start, let's go ahead and do this .gameObject.transform.position is going to be equal to start location .gameObject.transform.position. So that's going to set the location of this object. So when the game runs and we hit start and that thing's activated, it's going to find its start location node and put it where it's supposed to be. Okay, so the next thing is this .gameObject.transform.rotation is going to be equal to start location .gameObject.transform.rotation. So now the object will be properly positioned and oriented. We'll get to testing this later on after we actually have something to test. Oh, actually, maybe we can test this right now. So let's come back in here, and we have C1, C2, and C3. Those are our three characters at the moment. And under here, we don't have a start location, so let's just give them each a start location. So there's C1. We'll have them each start at different nodes. All right, let's go ahead, turn the controllers on so we can start debugging things and see if this works. Now with the run button running, let's take a look at our scene view, and we can see that each of those game objects has, of course, moved its position and orientation to match the location, or the start location it should be at. So that's good. Let's go back now into the script. Now we're going to start working with the editor itself. Now there is one thing that I'm going to do right now, and that is create a public animatronic node data array called node data. This might change in the future. I haven't thought completely through with this, but for right now I do need something that's going to store all the information on all the nodes and the associations of their weights and actions per node. And I do want to add one other thing. I want to add a public node. Right now I'm also going to store in each node the actual node as well. Right now I'm going to store in each animatronic node data a reference to the node as well. This might become the name. This entire thing might become a dictionary later on. I'm not entirely sure. I need to get a little bit further before I decide how I want to tackle this. Let's go into Animatronic Editor. Now we need to do a few things. Just naming it Animatronic Editor over here is not enough. The first thing we need to do is to using Unity Editor. Now it's quite possible I've lost some sort of references. Let's try to use something in Unity first. Let's do game object. Yeah, it's forgotten game object. So it's the tie's been broken. So let's close out of this really quick and open it back up. Okay, so we're back in here. Now that we've brought in using Unity Editor, the next thing we need to do is, of course, use an attribute called custom editor Custom editor, this attribute is going to specify which script this one should be replacing the default inspector with. And we're going to use type of to define the class, and then that is going to be animatronic. You can put any class you want in here. Remember, this name itself is just a convention, has nothing to do with which one it actually overrides. This is what does it. So there's a start and an update, but we actually don't need either of these. So let's go ahead and nuke them. And all of our code is going to be in one script area, and that's going to be in onInspector GUI. So let's do public override, if I can spell, override void onInspector GUI. Now we're getting an error here, and that's because we're inheriting from the wrong thing. We should not inherit from mono behavior. We should be inheriting from editor. Then everything works. Now inside of onInspector GUI, this is going to be in charge of figuring out exactly what to draw inside of our inspector for this object. So if we go ahead and save this thing out as it is, and take a look at our character nodes, what we're going to notice in just a few seconds once Unity updates, and it does take, a good 5 seconds or so for this to happen, on our animatronic script, we have absolutely no information there. None whatsoever, because we have overridden the default parameters for this, and no longer will it just pop out whatever public things we have. We're responsible for doing that if we want to still show that. If you didn't want to show that, you could use the draw default inspector function, and that will take care of drawing things the way we would normally expect them to be. So if I go back and go in and I wait for things to update really quick, here we are. Now you can see that the default way of visualizing things is right here. The script, the node, of course, and then any of the node data. I don't want this node data to just be like this, though. We're going to customize things. So we're going to get rid of draw and default inspector. All right, so the first thing, the most important thing to understand is we need to gain access to the target. That is, the target is the script that this particular instance of the editor is coupled to. When you select an object over here, we are selecting this object and we are visualizing the target is this particular animatronic script on this object. Therefore, we need to grab that. So we're going to do that by doing animatronic, and then we're going to call this animatronic script is going to be equal to, we're going to do a typecast to animatronic. It is simply an object, as you can see here, and we need to typecast that over to the kind of script we expect it to be, or the kind of target we expect it to be. So the next thing we need to do is add that start location back to this. So we're going to do animatronic script dot start location. Since we have access to that script now, we can access all the variables that we're used to inside of that script. So because this is public, it's easy for us to grab. And then we're going to use a function called editor GUI layout. Of course, GUI layout is a very simple way where we don't have to specify a lot of terms like where the GUI should be positioned on the screen. We can let Unity figure that out for us. And we're going to use something called an object field. An object field looks a little complicated, but it's easy. It's how we actually link up to things other than floats, bools, and whatnot inside of here. It allows us to hook up to objects. The first we're going to use not this one. We're going to use this one, this method where we provide a label. And that label is going to be starting node. That's the label we give the user so they understand what this field is actually going to be for. And we're going to next pass in the value that we want it to take on, and that's animatronic script dot start location. So you'll notice we're taking in the value, something happens, and then the value gets popped back out and stored in that animatronic script location over there. That's a very important thing to do. If you forget to store it, you can make all the changes you want to, but you're not going to see any updates actually occur. The next thing is the type of the object. We're going to use type of, and what we want to be in there is of type node. And that's pretty much it. We're still getting an error, and that error is because we need to typecast this over. This function itself is just going to bring out an object. Since we know what this object should be, it should be an animatronic script, we can just typecast this over to, not an animatronic script, a node. Okay, the next thing I want to do is grab a hold of the AI manager. So the AI manager before is a class with it's a singleton, and it gives us the ability to access it from anywhere using this instance. The problem is that this instance gets associated on the awake function, and this is not happening in the editor. We can't access it this way. We need to come up with a different way. And the way we access different scripts and things is actually by using the resource class And let's do that. So what we want to do is store AI manager. And it turns out we've got to do it as an array because it's possible that there are multiple objects in the scene, and that's what we could get returned is any AI manager that happens to be in the scene. And we're going to use resources dot find objects of type all. And we're going to grab the AI manager. So it's going to find all objects of type AI manager. Luckily, we only have one. And it's going to store them in this array for us. And this is how you want to access things inside of Unity, inside the editor. So what I like to do is just a quick check. I like to check to see whether or not the AI manager was even found. So let's do an AI manager if is equal to null. We're going to create a help box. The help box is, you've probably seen it before, especially if you've broken a reference to a script in your scene, like you deleted one and you forgot to remove the script from an object. What I want to do is create a help box that says scene must have an AI manager to populate nodes. And we can specify the message type, and the message type is going to be of type error for this. This will create a box if we're unable to find the AI manager up here. Let's fake this for right now. Let's copy this line just to show the box and that it works. We're going to comment this out, and we'll just set it equal to null. Come back over here. Give it a few seconds to update, click around, and eventually everything will freeze. And here you can see, scene must have an AI manager to populate nodes. Be nice if I spelled AI manager correctly though. Let's go back up here and manager manager. Undo that now that you've seen it work. Do this, save it, come back over here now, and see if that disappears. Once again, click around, give it a second to update, and there we go. So we know it can find the AI manager because that isn't happening. Now that we have the AI manager, the next thing we want to do is, let's do else. We're going to want to grab all the nodes from it. So I know I'm only going to have one in the scene, so I'm going to be a little bit nasty, and I'm just going to use access into the first element of the array. And we want to grab the nodes of that object. Now, this next line, I'm not entirely sure if it's required. This is just something I kind of came up with to make sure things work properly. So we're going to do Animatronic Script dot node data. If the node data inside the script is equal to null, meaning there's nothing there, it hasn't been set up yet, or the Animatronic Script dot node data dot length does not equal the length of the number of nodes that we actually have, so that's nodes dot length. Then what I'm going to want to do is actually regenerate things. This needs an actual equality. Basically, if we've got nothing there, or if the length is wrong between the nodes in the scene here, I'm going to repopulate that array. So let's go ahead and do an animatronic script dot node data is going to be equal to a new animatronic dot animatronic node data of size nodes dot length. Once again, not sure about this, not a pro on this one at all, but this just seemed to make sense to me. I just feel like at some point things are going to change and I'm probably going to need to repopulate things. So this kind of deals with that for me. Although I am going to lose any kind of information I had previously stored. So that's something we might want to think about in the future. The next thing we're going to do, actually, I do need to do one other thing. I do need to initialize that array. So let's just do a quick for loop for int I is equal to 0, I is less than nodes.length. And let's do I plus plus. And let's create each instance of that. Let's do animatronic script dot node data and do I is going to be equal to a new animatronic dot animatronic node data. So just populating that array. Okay, now that that's done, assuming this wasn't required, now we can actually go in here and present a GUI to the user for them to manipulate. So first thing we're going to do is use the editor GUI layout to make our life a little bit easier. We're going to do a begin vertical. So it starts vertical elements, very similar to Android if you ever programmed an Android with all their different view layouts. We're going to do now an end vertical as well. Within there, we're actually going to create a loop. And in this, inside of this loop, we're going to do a bunch of horizontal GUI layouts. So let's now do another loop. We're going to do another for int I is equal to 0, I is less than nodes.length, and I plus plus. So now we're going to begin editor GUI layout dot begin horizontal we just need, that's all. And now we'll end it as well, because for everything that we start, we should always end. We'll do .end horizontal. Now between these two, we're going to sandwich all the different GUIs. And what I mean by sandwiching them is, so we have our actual editor, we have the vertical one outside here, nice and big. And inside of that, we're going to have each individual horizontal one right here, 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 and there. And inside the horizontal, though, we're going to break it up to where we've got the name, like I said before, and then we're going to have the enumeration, and then, of course, next to that, we're going to have the bool value. So let's do editor GUI layout dot text area. We're going to do nodes I dot name. So this is going to create a text area where the names of these are going to be held. Let's save this, come out over to the scene view, give it a few seconds to update, as usual. Any second now, there we go. Now we're going to hit C1, and we can see already starting node, and of course each individual node. Now because we're using the layout, and because there's only one item in that layout, it's filling the entire space. Now as we add more items to this horizontal feature, that space is going to become less and less for each individual component based upon how much space the individual ones need. Create the action enumeration field, and then we're also going to do the toggle Boolean field. So as before, we need to make sure that we store any of these values out. So we're going to grab the animatronic script.node data, and we're going to do this for the ith element, and we're storing the action in this case. Let's see, and that's not working because these need to be public. Now, I believe in C++, using a struct is basically a class where everything is natively public, but apparently in C#, you still need to define each one individually as public. Now we should be able to do .action. We're going to set that equal to editor GUI layout, and that GUI layout is going to be enum popup. Inside of enum popup, we're going to specify the enumeration type, or the actual variable that's going to hold it first, and then any kind of additional parameters, but we don't need to really worry about that at this time. So let's do animatronic script dot node data as before, the ith element dot action. So we're grabbing what it is, we're putting it in there, and then of course we're shoving it back into action when we're done. So there's still a problem though, and that's the fact that this is just a generic enumeration. We want to typecast this over to the correct kind, and that of course is going to be animatronic dot actions type, and that should work. All right, so that's that GUI element. Let's make sure it works. Come back over here, move around really quick, make sure everything updates. There we are, and you can see right there, stage, and we can go in here and change them to be whatever we want. Coming back over here, let's do the last bit of this and end this video. Animatronic script dot node data I dot weight is going to be equal to, we don't need to typecast it this time, George. We just need to do an editor GUI layout dot toggle. So toggle is for Boolean values. So inside of this, we're going to do animatronic script dot node data ith element dot weight. Semicolon that on the end. Wait for that to finish up. And that's pretty much it for this. Come back over here. Move around a wee bit, and there we are. So we have our different objects. You'll notice each one is independent. It's storing all of its own information. We can choose whatever Boolean values we want to. Come over here, make changes to each of these as well. This one, we'll leave this one as it is, but we'll set everything to be true. I can go anywhere. And let's do the big test to make sure everything gets saved. Let's hit the save button first. Hit the run button now. So everything goes to its respective starting locations. We come over here and look here, and it looks like our values have been stored and saved as before. And if we click play again, our values are still there thanks to the serializable that we added to our individual classes. Okay, so that pretty much ends it for this video. Didn't want this one to go on too long. In the final version of this, obviously, we're going to have, instead of node 341, it's going to be like party room, bathroom, kitchen, etc. And then we're going to get to choose what pose the character is going to take at that location, and then whether or not that character is even allowed to be at that location either. Because of this, we're going to have, I believe the starting location is going to have 3 different positions, because we have to have one for each of the main characters who happen to be up on the stage. This is great. So in the future, when our AI manager has the transition actually happen, all we need to do is call the animatronics, update method basically, The animatronic itself has a list of the node it's at. It also has a list of all of its own nodes that it can go to. It should pretty much be able to figure out just about everything. I mean, from the node itself, it can grab every node that this node is connected to, since we've already programmed that in. And then it can check to see whether or not the weights of those nodes work. We will need a way of taking in the node here and, of course, converting it over into something that we can access, basically. Something that will feed into this struct, this object right here, array of structs, and make it so we can find it. That's why I was mentioning maybe a dictionary or something else like that we'll store in here as well. That means that the character can control pretty much all of itself. All the animatronic, the AI manager needs to do is, tell it, hey, it's time to move and get your butt moving. All right, everyone, I hope you enjoyed it. I found this pretty fun because it gave me an excuse to dive into the editor and make some interesting stuff. Thanks, everyone. Have a good night. Bye.